Welcome to a piece of history. This is a historical room that's been here, and I forgot to look up when Burkhart Building was built, but I'm guessing this room has been here since 1950. This was the first central office location on campus. At that point in time, everything was powered and all the connections came from the central office downtown from AT&T, and at that point it was Indiana Bell, and so everything in here was passive. There was no need for electricity other than lights. That's why you could run water cables through the roof of a wiring closet. You didn't have ventilation, air conditioning, we have to keep the equipment down to certain temperatures. We try and keep it between 70 degrees and 82 degrees. That's kind of the sweet spot. Once it hits in the 80s to 90, we get alerts. All of our phones go off, all of our computers go off, alerting us that the temperature in the room has risen. Something else, we have to condition the electricity in the room. Because we're pulling so much power every day, you'll learn with electronics you have to have clean power. We are on an AC signal, so we can't have dips and we can't have spikes. Electronic equipment does not like that. This is also a demarcation area. This box right here was installed with the ERP program, Enterprise ERP, where we combined all of our servers into one secure area. Enterprise Resource Planning. Okay, so this is a demarcation. AT&T was allowed to come in here and bring their circuits in through fiber cable out. They then take it down to copper. We then interface, and this becomes a demarcation point. And you'll learn the term demarc. That's where the plain old telephone services ends and the customer service begins. That's a definite point. You will learn that. Some of you will be in charge of rooms like this and oversee rooms like this. Some of you won't, and it won't matter. But you can see in the past all the copper cables that it took to run telephones across campus. This is how the voice network, the POTS network at that time worked. And as you're aware, and you'll learn the term POTS, that it was just a single line analog telephone. Since that time, they brought in digital sets, and way back when, and I don't know if you'll learn this term, it's called 1A2 key. Those were also analog, but now digital sets have come in. We are migrating away from the copper field, and we are now moving toward voice over IP, which Chuck will talk about in a minute. So from my perspective, being in communications and taking care of wiring and cabling, we have a lot of generations here. Most of that copper was put in 1986 when Ray Steele brought the Timkoff project to Ball State. At that point in time, AT&T agreed to come in and put fiber optic cable and copper cable into the university in return for us buying phone switches. And at that point in time it was called the ISN, which was basically a big modem network that allowed people to have terminals in their office. Before that time, some select people had terminals and other people had to come into the building and use terminals in the building. So I can kind of show you history here. Follow me. It's a little warmer back here. And we can squeeze down. There's an aisle back here. Let's squeeze down these aisles. It's a little warmer back here. So in the beginning, there were the gray cables, and you'll see the gray cables up above you. Those are category 3 cables. We've tried to do every generation new a different color. So you'll see not these yellow cables, but there are yellow cables in here, copper cables, which are Cat 5, and I can't show you those. And then when we went to Cat 6, we went to blue. My understanding is Cat 7 will go to aqua. No. It's a purplish, and there are a couple cables right there, but those are Cat 6. But the next generation will be a different color. That way that your technicians and people that are out working on there can kind of gauge from sight what they're working on and what they're getting into, what we like to call no-brainers. If the cable is in a certain color, we need to check the numbers on the outside and see if we need to update it to bring it up to the most current standards available. This fiber field here that is orange was original Timkoff fiber put in 1986. You'll see it is still in operation today. That was a great investment for the university, and we still use this. Now, the limitation on this orange fiber, which is multi-mode, is less than 1K, less than a mile. The GBICs that power it are 850 feet. So we could get about 1,000 feet from this building on a piece of multi-mode fiber cable. The next generation followed the 86. In about 90, 92, we started putting single mode in. Single mode fiber is yellow. You can see that it has an ST style connector. These are old connector styles that are in use today. So that extended us with this style fiber to 1.2 kilometers from here. So we gained a lot of distance. As new fiber became available, it is still yellow, but it has a different center on it. It's still single mode. We can get up to 10K off of certain GBICs and certain fiber. What we have on campus here are 10K. We have 10K fiber we can get anywhere off campus. It all depends on what laser you're using inside of the GBIC, because multi-mode uses LEDs where single mode uses laser. You can see there's massive cables, and trying to keep track of this spaghetti factory when you have lots of hands in here is a chore. So documentation is really important. You need to keep good documentation. You have people come in behind you and leave cables dangling. So now I will have to come in here and follow that cable and see where it goes and where it went and take it out and get it out of here. Obviously somebody has something planned here, so we'll have to figure out what they have planned. Leaving a door open is unexcusable. You can see I carry a radio. It's real easy to catch a radio on a cable sticking out of here, just like a backpack. That's why we ask you to leave backpacks out there. But you can see as we migrated, the real estate becomes smaller and smaller. Because these rooms, you can see this room is here since 1950. We have a lot of people come in here. That's why there are chairs. So people must be in here taking a break when we're not down here giving tours, which is not a good thing. We don't need many hands in here. We have HVAC lines going through here and this big air handling unit behind you. So that means we have HVAC people in here working. We have electricians in here because there are electrical panels on this back wall. We have electricians in here. Because we have water pipes going through here, which is a no-no in any wiring closet, we have plumbers come in here. Recently, back over in the middle of here, we cored holes in the floor to allow jacks to be put in the floor for classrooms. The classroom right up above us, the new electronic classroom up there. If you haven't seen it, walk by, take a peek in there, and you'll see what I'm talking about. We put up enclosures here to try and protect as much of this as we can to make it safe and reliable, because once the network goes up and down, people begin to lose confidence in it. You got to have confidence in your network. This right here is our core switch. This switch right here, all the buildings on the south end of campus connect into here. We have a switch down here that connects to our ISP. So the internet is coming into this building. It gets filtered, it comes in, it gets shot down to intrusion detection stop firewalls, because there are people every second of every day trying to break into our network that want to take it down. That is their goal in life, is to destroy our network, and we have to try and stay one step ahead of them. We have wireless controllers. These are what control how you get onto the wireless network, your authentication, and lets you on or does not let you on, and puts you on certain networks according to how you get on to, according to how you log on to the network. We have these are the new 6800 redundant core switches. The buildings connect here, but these connect Robert Bell to Burkhardt. What we have is we have a fully redundant network out there with fiber cable, so that if somebody takes a backhoe and takes out our fiber cable between here and Robert Bell, the south end of campus will continue to work and go out the ISP to the internet. Robert Bell will continue to work and go out the ISP there until we can get that cable repaired. We have a fully redundant network. We use what's called an N+1 setup, where if all of the equipment failed here and it still had cable going to the other end of campus, we could still work. We might have degraded services, but we still continue to work. We are here every day. We have several people all day that's what they do all day long, is make sure the cables are in and working. With that said, you can see that as time goes on, you become crowded and you're trying to find more real estate for everything that you do. It's just part of the game. Why are we in a 1950 room with being the South Core? I can't answer that question. All I know is I get paid to keep it up and operational, and I like getting paid, so I'm going to do that. We have cable TV, so we have cable TV people coming in here. And it's a full-time job just keeping people in who need to be in. Because we have so many people in this room, we had to install cameras. So that camera is right above your head, so we can see people. We know when the temperature rises, we get on that camera right away, because we've had people leave that door standing open. So we know the door's open, so we run down here and shut the door. We don't have to call anybody else. If the door's shut, we know we need to get the HVAC people in here to get things going, because the warmer these devices get, you'll learn the slower electrons go. And electrons don't like to be hot. They like to be cool, but not cold, and they will go through the circuit boards and through the wires at a much better rate. We have 10 gig connections that go from here to Robert Bell. We have 1 gig connections into buildings. We have 1 gig, 100 meg, and 10 meg into different devices across campus. We're trying to get rid of the 10 megs as we go along, but there are some legacy systems out there we can't get rid of that will go away at some point in time, but that's a matter of time. With that, that's about all I have. You can see by this wall that we have water seeping through the wall. It's causing paint to chip off, which causes water to run down. We had to raise the floor. This floor is elevated. We have water sensors under the floor that connect up to boxes that give us both reading on moisture under the floor and temperature of the room, humidity. We measure the power. When the power dips, we have all kinds of measurements which we have to do daily. So we used to put all of our equipment on plywood backboards, and you can see this would be a mess on plywoods. We've now migrated into what are called racks. Racks are prominent. Some people use racks on wheels, some people don't. This is just what we have, and this is how it works. I'm going to turn this over to...
How do you deal with the plumbing situation? I mean, if you had a plumbing leak, what do you do? We come in and cover it with plastic. You can see, look right behind you. So we have to run in here, cover it with Visqueen,
so that the water is not dropping on top of the active equipment. That's all you can do. You have to keep it operational, and being a graduate of this program, I'll tell you right now, throw away the calendar, because there's really no calendar. It's 24/7, 365. You're going to be lucky. You're going to have to schedule your vacations way out in advance, and sometimes they get denied depending upon what type of group you're in. I will tell you, this program is designed to make you learn a lot, learn very quickly. They're going to run you ragged. They're going to make sure that when you're tired, when you're hungry, when you're thirsty, you can think on your feet, you can stand up and give a presentation, and you can put people together with technology, using business practices, and being able to be successful. So if you use the program effectively and wisely, you will go out and you'll find a job. I don't care if it's selling shoes, I don't care if it's making rocket ships. You're going to find a job, and this is going to prepare you for your professional career. So don't get all caught up in the pecking order and say, oh, they're a techie, they're really smart, because that may not be what field you're going into. Take the knowledge you have, put the people together with the technology, and utilize it to make yourself a paycheck and a professional career. I'm going to turn you over to Chuck and let him.
All right, so does everybody have a handout? Does everybody have one? Okay. So at the top of the handout, you'll see some information that just kind of talks about the history of our group. We used to be, Unified Communications used to be 3 separate groups. The telephone services, the video conferencing, and the data networking group. As the technology has progressed, and as voice service and everything has been slowly moving over to network-based, the university took those 3 areas and combined them into one unit, so that instead of maintaining separate networks, we could all combine functions, combine duties, combine the technology onto one network, and that's where the Unified Communications project started up. We are in the process of migrating from the Avaya TDM standard PBX to a Cisco Unified Communications platform. That new platform is going to be completely voice over IP, which means that all endpoints will run on the same network that your computers plug into. Also on this handout is a link to a NOC page that gives you all kinds of real-time statistics on the Ball State campus network. It shows you how much real live data is passing between the university and the commodity internet, how many connections and what bandwidth are being used by each building. It's a good tool as you work on projects and as you work on papers. If you need to have an idea of real-time statistical data, or just a whole bunch of information, that's a good resource to use and to start with. Pretty much every graphic that's on that page is clickable, so you can drill down into greater detail to take a look around. So it is a tool that, like I said, you can use for presentations or papers. The Ball State Help Desk also uses it as a way to determine system status and where there might be problems and issues, so that they know before they start getting the calls. But pretty much everything that you see in the top half of this rack goes with the communication manager system. You see these big cabinets right here. These are telephone cabinets for the Avaya system. We have multiple cabinets spread around 10 different telephone rooms on campus serving that specific area. So think of, we've got about 15 or 16 of these all around campus. This is going to be replaced with 4 virtual servers and a couple of other pieces of equipment located here and in RB. So one of the things that we're going to accomplish is we're going to reduce the carbon footprint, the amount of energy consumption, and the amount of heating and cooling that has to go, or the amount of heat generated and the amount of cooling that has to be created to offset that by moving to this solution. The primary voice system, or the voice processes all of your voice calls, is the Cisco Unified Communication Manager. All of these things that I'm going through, unless I specify otherwise, are virtualized servers that are running on one of these 4 right here. The Communication Manager solution has a publisher and 4 subscribers. So if you think of it as, the publisher is the server that we log into and we make the changes to all of the system, we make the changes to all of the voice endpoints, all the gateways. We do all that within the publisher. Then the publisher takes that information and then it sends it out to all of the subscriber servers. The subscriber servers are what the phones actually register with. So when you plug in a phone and the phone goes out on the network and it looks for the call manager and it needs to get that information, what extension number am I? How many extensions am I able to answer? What happens if I'm called and nobody answers the phone? It pulls that information once it registers with the server, and we have 4 of those subscribers. We have 2 located here, 2 located in RB, and we have it set up so that if this location went completely down, the 2 subscriber servers that are in RB would be able to handle the load. So if your phone was registered here and this room went completely dark, then your phone would drop. It knows that there's another set of subscribers that it can register with, so it'll register with those at that time. So redundancy and survivability were 2 main factors that that factored heavily when we chose this solution. We wanted to make sure that everything was physically and software redundant. Once you get past the communication manager itself, you have the Unity Connection Server, which is your voicemail system. The Unity Connection Server provides voicemail capability, so that if somebody calls your phone, you don't answer, they leave a message, that message is stored inside of the Unity voicemail system. Your Unity voicemail boxes are integrated with the campus email system. So when a message is left in your voicemail box, a copy of that message is also shows up in your Outlook email inbox. Since they're integrated, if I delete it from my email, it's also deleted from my voicemail box. So you don't have 2 places that you have to administer this stuff. It's integrated. Whatever I do in email happens in voicemail. Likewise, if I still would like to log in through my phone to listen to my messages and I delete it from my voicemail box, it'll disappear from my email inbox as well. The Unity Connection Server also provides menuing, so that if we've got some departments that may not have a administrative coordinator answering all the calls, or they may have a single administrative coordinator and no backup, so they use a menuing system so that if it's after hours or if it's during the day and nobody answers the call, then the menuing system picks up and presents the caller with a list of options. That's also a function of the Unity server. And then the third main component is the Unified Presence server, the CUP server. What Unified Presence does is it gives us the ability to have instant messaging. It gives us the ability to have presence. What presence allows me to do is it allows me to see whether you're on the phone. Presence is integrated with your Outlook calendar, so I can see if you have a meeting scheduled, your presence automatically updates to say you're in a meeting. It's a way that we can know the status of the person that we're trying to contact, especially for an administrative coordinator or somebody that is a main answering position. they can use presence to have a better idea of the status of the person that the caller is looking for. The old style way that we would do that is by giving you a busy button on your phone of that person. Well, the only thing that a busy button would tell you is whether they are physically on the phone. If they're not on the phone, you don't know if they're in their office or not. You don't know if they're available or not. With presence, not only will I know you're on the phone, but that integration with your calendar tells me whether or not you may be available. And then presence also allows you to customize your status so that if you were in a meeting or if you had a student come in to speak to you, you could update your presence to say with a student or unavailable, or I'm in the Burkhart frame room, you know, all that kind of information. So
will that be ubiquitous?
we're in the process of doing that right now. So we are migrating IT right now so that we can make sure that we get our procedures for the migration process done, billing issues addressed, all that stuff, hopefully taken care of in-house before we really start going out and hitting the rest of campus. So so those are the three main components: the Unified Communications Manager server, the Unity Connection server, and the Presence server. As far as endpoints that are available, what do I use to actually make or receive a call, or what do I use to use Presence or instant messaging? Well, as far as a physical telephone goes, we've settled on two models. We've got a 7861 and a 7841. Both are Cisco phones. They're basically the same phone. The only difference is that the 61 has the additional buttons on the side. The intent for that phone was it would be a main answering position or a receptionist type of phone, because typically they answer their lines and possibly, you know, the dean's line or the director's line or other people within the department. So they typically have more needs as far as physical buttons go. The smaller phone offers the same functionality with fewer buttons. I can have up to 4 lines appear on this phone, and this is the phone that we are using as the standard replacement for the analog service on campus. So the analog service are the old gray phones that you may have seen on people's desks or spread around campus. This is the phone that we're migrating those folks to. We also offer the Cisco Jabber solution, which is a soft phone, which is the instant messaging and presence client. It is a piece of software that will run on your computer or your laptop. It can run on your smartphone. It can run on your tablet. If you, say for instance, myself, I'm only responsible for answering my own line. So I don't have a physical phone on my desk. I only use the Jabber soft phone running on my laptop in conjunction with a headset. I take all my calls on that laptop. If I'm out and about, like today, if I'm working down here all day, I can still make and receive all the telephone calls that I need to, and have access to the instant messaging and the presence. What if you have a physical desk phone on your desk? Well, you still run the Jabber software. You still use it for instant messaging and presence. You can still use it to answer your line or to place a video call with another person that might have Jabber or a video phone, but it may not be your main answering position. One of the cool features within Jabber is that you can tell it what's going to be your main answering position. Is it going to be your computer, or is it going to be your desk phone? If you choose your desk phone, then let's say you get an email and that person's email has their phone number in it and you want to give them a call. Well, instead of picking up the handset and dialing the numbers, you can double click that person's phone number in their email. It'll actually send it over to your phone. Your phone will go off hook and start dialing the number for you. So you can still use Jabber to integrate your voice functions and still have a desktop telephone on your set or on your desk. We have people that within IT that you know, have conference calls and such after hours, and they were burning up a lot of time on their cell phones. So by moving them to the new solution, they have a desk phone on their desk, but they have Jabber installed on their smartphone. So when they're out of the office, they start up the Jabber client on their smartphone, they make the call, and the call comes through the internet to the call manager and then back out to the outside world. So even though I'm sitting at home on my wireless network, I'm still placing a call from Ball State to the end user. It's my 285 number. They have no idea what my cell phone number is, so that's not exposed. So I haven't just given someone my personal cell phone number. And if it's long distance, if it's toll-free, it doesn't matter. It's coming through the campus network. I'm not using any of my minutes. I'm not using any of that service.
I want that.
Yes. So that's kind of like what provides the core of our service that we offer in the UC solution. We've got supplemental servers and supplemental equipment that goes along with that. And the first set are what you see here, which are the VG224s. And what those do, and you have to update your documentation. I wrote VG221 on there, trying to do it from memory. It's actually a VG224. And what that is, it's a 24-port analog gateway. So this gateway registers with the call manager. It provides 24 ports for analog dial tone. So you see the back of this has a 25-pair Amphenol cable that's extended over to the wall and broken out onto those 110 wafers that you see over there. Every pair is you think of it as a separate analog extension. So what that allows us to do is take your fax machines or an elevator phone, or somebody has a credit card machine, something that has to have analog dial tone. We can provide that, but still use a voice over IP or a network-based solution to provide that dial tone. So it's the same concept as, instead of programming a phone and giving it all the information of one of these phones, you set it up as an analog port within this analog gateway, and that allows us to provide that analog dial tone from here to the jack at the far end. Now, the only difference between the analog gateway design and the design of everything else is that we don't have 100% redundancy of that. So every extension that is active on this gateway, if that gateway goes down, all of those extensions go down, because it's a physical connection to the wiring that comes back to here. I can't have it register someplace else. I can't have it automatically be taken over by another gateway, because it's a